So number 2 on your worksheet. Okay, we've got Mervyn the Menace drops a water bomb from his apartment window. If you drop something, how fast is it going when you first let it go? What's its initial velocity? That's its acceleration. Its acceleration is 9.81 meters per second squared. That is definitely a number we're going to have to use. Okay? But if I drop something, right now I'm just about to drop this. How fast is it going? 0. Anytime you see the word drops, okay, that's starting from rest. Okay? So we've got VI equals 0 meters per second. We just finished saying the acceleration is 9.81 meters per second squared in a downward direction, and it's going to fall for 4.25 seconds. Okay, what we're looking for here is VF. So our formula, A equals VF minus VI over T. What's the first thing I move? T. Right, so I multiply both sides by T. T cancels on this side, T comes over here. Now what do I move? VI, by adding it to both sides. Okay, so if I go plus VI, my VI cancels here, I add VI to this side. Remember, there's only 2 rules for algebra. What you do to one side, you do to the other. If you want to move something, do the opposite. Okay? Alright, now we've got our formula, so now I can plug in my numbers. 0 plus 4.25 times 9.81, okay, will give me my final answer. Okay, so 4.25 times 9.81. I don't have to put the plus 0 in because it doesn't make any difference. Alright, so my final velocity, okay, is 41.7 meters per second. No, not per second. No, not squared. This is a velocity. It's only in meters per second. Down. It's a vector quantity. Okay? One of those things we got to be mindful of. Did it ask for speed or did it ask for velocity? If it asked for velocity, it needs a direction. Okay? So, 41.7 meters per second down. Okay? Ringing a bell? Alright, let's get to work on that sheet. We'll go over any ones you want to go over. Okay, so if you're stuck on one, just ask. Right, and we'll go over them. Okay. Yes. Alright, so on this one here, which is supposed to be number 7, even though it says 1 here. Okay, car slows from 22 meters per second to 3 meters per second. Okay, 22, initial or final velocity? If it slows from 22 to 3, it was going 22 at the start. Alright, so we're starting at 22 meters per second. That's our initial velocity. And we're slowing to 3 meters per second. Okay, with a constant acceleration of negative 2.1 meters per second squared. Makes sense that this is negative if we're slowing down. Alright, so we're trying to find time. So A equals VF minus VI over T. If I want to solve for how long it takes, that's time. Multiply both sides by time. Okay, so T cancels over there, comes over here. Divide both sides by A, and I've got VF minus VI over A. So time equals 3 is VF minus 22 VI over negative 2.1. Okay, when we do that, we should get 9 seconds. All right, everybody with me there? Okay. Any other ones besides 16? 5? Okay. That's the right one? Yeah? All right, so a car is coasting backwards down a hill at negative 3 meters per second. All right, so that's VI. Negative 3 meters per second. The driver gets the engine started, and after 2.5 seconds, the car is moving at positive 4.5 meters per second. What's the average acceleration of the car? All right. If I'm looking for acceleration, do I have to manipulate the formula at all? No, it's already set up. As long as I get the positives and negatives right, I should be okay. All right, so VF, we said, was 4.5. Okay, minus the initial velocity, -3, and that's where it's important that the negative comes in there, over, sorry, that should be a T, over 2.5 seconds. Okay, so we get 7.5 as our top divided by 2.5, and that should give us positive 3.0 meters per second squared. Yeah? Make sense? Okay, any others? All right, keep going then. Okay, so once we, actually, we go back to the original givens here. It starts with a velocity, okay, of 2 meters per second, okay, positive. The acceleration is negative 0.5 meters per second squared, and now our time is going to be 6 seconds. All right, so we're looking for VF. Okay, so A equals VF minus VI over T. Okay, so we multiply both sides by T, divide both, or sorry, and then add VI to both sides. So we have VI plus T times A. So that'll be positive 2.0, okay, plus 6 times negative 0.5. With me there? Okay, so when we do that, we should end up with -1 because 2 times -3, or sorry, 2 plus -3 is -1 meter per second. All right. Any other ones? Alex? 19, okay, I'll do 16 before I do 19 because Dom asked for that one a while back. Okay. Oh, 16, I didn't take the stuff off here. All right, let's start that one over. All right, so we have a particle moving with a velocity of 112 meters per second at time 0 seconds. So VI is 112 meters per second. It has no acceleration until time 3 seconds, after which it accelerates at -4 meters per second squared. Okay, what is the velocity at time 16 seconds? How long is this particle accelerating for? 13 seconds. That's the trick. Okay? It tells you all of this stuff, but it isn't accelerating all 16 seconds. It didn't start accelerating till 3 seconds. Okay? So the time in this one is actually only 13 seconds. So all this question is telling you is it's illustrating the importance of reading the question carefully. All right? So time is 13 seconds. So VF will be the same as it was before. VI plus T times A. Okay? So that'll be 112 plus 13 times -4, okay, and when we do that, we should come out to positive 60 meters per second because we're subtracting. All right, is that okay? All right, and then 19, Alex? Okay, so we got this truck traveling at 33 meters per second due east. I'm going to assume that's VI, okay? Okay, and I'm going to make east positive. All right, it comes to a halt by decelerating at 11 meters per second squared. If it comes to a halt, what's VF? Nope. 0. Okay, if you come to a halt, that's coming to a stop. That means you are not moving at the end of the question, so VF is 0. Okay, and it decelerates at 11 meters per second squared. Since it's decelerating, that means that that has to be negative. All right, so there's a couple of tricks in that question. Now we're looking for how fast is the truck going after 1.8 seconds. So we actually don't need... At the end of this question, VF is 0, but they're saying before that happens, after only 1.8 seconds, how fast is it going? So again, it's a question you got to read carefully. They gave us a piece of information we're not even going to use in this question. Everybody right with that? Okay. So we're looking for VF. Okay. We don't know what it is because we're not talking about the whole trip. We're talking about only 1.8 seconds into it. Okay. So VF again will be VI plus T times A. So that'll be 33 meters per second east, okay, plus 1.8 times -11. All right, and when we do that, we should get 13.2 meters per second, but that should be not positive, but east, because that's what they gave us in the question, east. All right, Kurt? 11? Yep. All right, so a bike rider accelerates to a velocity of 7.5 meters per second. If he accelerated to that, is that his initial or final? Final. Okay? If he accelerated to that speed, that's his final velocity, meters per second, during 4.5 seconds. Okay, the bike's acceleration was 1.4 meters per second squared. What was the initial velocity of the bike? So we're looking for VI. So A equals VF minus VI over T. This is the most difficult manipulation of this formula, solving for VI. All right, first thing I'm going to do, multiply both sides by T. Then I'm going to add VI to both sides. So it comes over here like I'm solving for VF. Now, I want VI to stay over here by itself. What do I do with T times A? Not divide it. Subtract it. Right, so VI equals VF minus T times A. If I was moving just T or A, I would divide. But I'm moving the whole term, and I'm adding it. So I subtract it to this side. Okay? All right, so that means then 7.5 minus 1.4 times 4.5. Okay, when we punch that in, we should get 1.2 meters per second as his initial velocity. Okay. Any other ones? No? Okay, so this is a three-part question. You've got like three separate things here going on. Okay, so it starts from rest, so I'm going to go in part 1. Okay, it starts from rest, so VI is 0 meters per second, accelerates at 2.01 meters per second squared, okay, for 7 seconds. Okay, at the end of this time, the boat continues for an additional 6 seconds with an acceleration of 0.518. So I need to know how fast it's going at the end of part 1 so that I can have an initial velocity for part 2. All right, so that's what I got to do first, is find VF here. So VF will be VI plus T times A. Okay, and so that's going to be 2.01 times 14. And it's got to be on. Oh, 2.01. Okay, so we're going to get 14.07 meters per second. All right, so for part 2, I can now write down the givens for part 2. VI is 14.07 meters per second. All right, the acceleration is positive 0.518 meters per second squared. Okay, for an additional 6 seconds. Okay, what do I need to find out about part 2 before I can do part 3? Yeah, the final velocity. So it's exactly the same calculation I did here. Okay, so VF is going to equal VI, 14.07 plus T times A, 6 times 0.518. Okay, so VF for this one. All right, so 17.178. Okay, so VI equals 17.178 meters per second. Okay, following this, the boat accelerates at negative 1.49 meters per second squared for 8 seconds. Okay, what's the velocity of the boat at time 21 seconds? Well, if you add all these times together, they add up to 21 seconds. So it's basically what's the velocity at the end of part 3? Well, it's once again the same calculation. VI plus T times A equals VF. Okay, so you plug in your numbers there. 17.178 plus 8 times negative 1.49, and you should get 5.28 meters per second. How slightly smaller? So you got 5.26? Yeah, close enough. Yeah. Right. Could be that I didn't carry all my numbers through or whatever, or I rounded off when I made the key early. I probably shouldn't have. That's probably all this. So if you did it this way, you did it right. Okay. Any other ones? All right. Keep working then. I'm going to post tomorrow's quiz here at some point.